Hi students, good afternoon. So I am Kaushik Das. First of all, I am introducing myself. I have 22 years academic and industrial experience. Last 8 years I am working as a lecturer in a reputed engineering college, Soroj Mohan Institute of Technology, Diploma Division. And last 3 years I am working as the head of the Department of Mechanical Engineering Department. And I have completed MTech in mechanical engineering in a government engineering college. So today I am going to teach you simple stresses in machine parts. So first of all, we have to know that different forces that acts on a body and the factors for which the forces acts on the body. So the factors are, first of all, you have to know the factors which influences different types of forces, that is weight of the body. Number 2, energy transmitted. Energy transmitted. Number 3, inertia in reciprocating parts. Reciprocating parts. Number 4, lack of balance of moving parts. Number 5, frictional resistance. Frictional resistance. Number 6, changes in temperature. Changes in temperature. So this influences very much forces when forces acts on a body. So next we have to know that what are the forces. So there are different types of forces, say tensile forces, compressive forces, and different types of load, and we can consider load also as a force, like dead load, live load, gradually applied load, suddenly applied load, impact load, etc. So for this purpose, when the external loads or forces acting on a body or in a machine parts, some internal resistance or reactive force or internal force acts to resist the external forces. So the internal forces or reactive forces per unit area, that is called stress. So there are different types of stress. We know tensile stress, compressive stress, shear stress, bending stress, compound stress, torsional shear stress. So different types of stresses. So today we only consider the tensile stress and the compressive stress. So first of all, we have to know the formula of the stress. So what is the formula of the stress? So we can write that stress is a ratio of force per unit area. So we can write it like this way: stress is equal to force per unit area. So here we can write P is equal to force or load on the body, and A is equal to cross sectional area. So in Greek letter, force is denoted by letter sigma. Sigma. So we can write sigma is equal to P by A. So what is the SI unit of stress? That is, we can say Pascal. That is Newton per meter square, or megapascal means 1 Newton per millimeter square. So this is the SI unit of stress. Next, we have to know what do you mean by strain. So we can say when external force acts on a body, some deformation may occur. So deformation per unit length, we can say strain. So strain, we can say delta L by L. Delta L is the deformation of the body and L is the original length. What is the formula of strain? So we'll discuss. So strain in Greek letter, strain can be denoted by epsilon. So we can write strain is a ratio of delta L by L. So here delta L is equal to deformations of the body. Deformation of the body. L is equal to original length of the body. Okay. So now we discuss what do you mean by tensile stress and compressive stress. When two equal and opposite forces or pulls act on a body axially, then the internal forces or reactive forces is generated into the body. So we can say these internal forces per unit area, that is called tensile stress. So we can write it like this way. Tensile stress, when a body subjected equal and opposite axial pulls, then the tensile stress is generated. So we can write tensile stress is a ratio of P by A, that is reactive force per unit area. When the tensile force act, the length of the body is increased and the cross sectional area of the body is decreased. And what is the SI unit of tensile stress? So we can write it as Newton per meter square or Newton per millimeter square. So that is, we can say that is SI unit of tensile stress. So what do you mean by compressive stress? So we can say when two equal and opposite pushes or forces acts on the body axially, then the internal forces or reactive forces is generated in the body. So these internal forces per unit area, we can say that is compressive stress. And in compressive stress, the length of the body is decreased and the cross sectional area of the body increase. So we can write it here. Compressive stress. So when a body subjected to two equal and opposite axial forces or pushes, then the compressive stress is induced in the body. So we can write it here. So we denote it as sigma c. So sigma c we can write as P by A, that is force per unit area, and unit of compressive stress same as tensile stress. Now we will discuss about the Hooke's law. When the external forces or load act on the body up to the elastic limit, stress proportional to strain. That is called Hooke's law, and from this Hooke's law we can get the Young modulus. So how do you get Young modulus? Just see. So we can write here Hooke's law. Hooke's law. When the external forces or loads act on the body up to elastic limit, stress is proportional to strain. So we can write it here sigma proportional to epsilon. So we can write sigma is equal to E into epsilon. So here E is equal to constant of proportionality. So we can write E is equal to sigma by epsilon, or stress by strain. So what is the meaning of E? E is equal to Young modulus. Young modulus. So today we'll complete these sessions. Next day we'll discuss about the bending stress, shear stress, and torsional shear stresses. So thank you for today's session.